So hi, I'm Mike. I work at a company called. Is that simple? Here's what we do. You will have seen these before if you visit Stripe or Twitter or Barclays, or you just buy things online or send websites secrets. This is EVSSL. You might have seen it, you might not know what it means. It means this is a real company in the UK. It means they're registered at company's house, have a verifiable physical address. The person who requested the certificate has sufficient authority within the company to do that, and a bunch of other stuff. They're getting quite popular. Third one down there is ours. But they're also, they take a really long time to get. If you've got an EV certificate before, or if you know anyone who does, like the NPM guys, typically they waited a month. Actually, the application process is an hour of like stuff, giving a whole bunch of details and like typing stuff in an OpenSSL in command line. Then there's a 7 to 21 day standard industry wait to do that. Our application process is 80 seconds. We do everything for you. So we actually generate a shell script or a PowerShell script for Windows users, which there are probably two, that you just paste in your terminal and it builds a CSR for you. You paste the CSR back into that. And while you're actually doing that 80 seconds worth of work, we check your details. So when you start typing a company name, we're already checking for active company names at company's house because we geo-IP'd you and with the name you're entering. When you enter in server names, we find the ENS record that matches the A record for the server names, we find the who is for that. We fuzzily compare the admin contact and the who is against the legal name at company's house. You won't see any of that if you use Cert Simple. All you'll hopefully see is you'll get to the final page without any warnings. We tell you if there's something wrong with your company, in most cases, before you get to the end of that 80 seconds. And yeah, we do EVs in 5 hours, we're rad. That's not what I'm here to talk to you today about. By the way, when Node comes out, Node version 2, whatever after the Node Foundation is, we did the TLS cipher order in the next version of Node. Our whole app is NPM. So we use NPM on the back end, NPM on the front end. All our own code is NPM modules. Some of them are open source, some of them are proprietary, but everything is NPM. So this is to talk about why we chose NPM, how you can use NPM, and things to avoid. Why NPM? Because that's where all the packages are. There's Bower. Bower's dead. NPM is growing like crazy. To give you an example of that, when we were thinking about using NPM in the browser, this is probably the second project I've done using NPM in the browser. Every single thing not only was on NPM, but was officially maintained. So Stripe, a couple of years back, there was some guy who wrote a Stripe module. Now it's Stripe.com's official module maintained by Stripe staff. It's on Stripe's GitHub, and you can report issues on what you did an NPM install on. Same thing with Ractive. Ractive is by the Guardian guys. It's a very simple live binding framework. If you can remember, var binding equals new Ractive L, where to put it, template, a mustache template data, some JavaScript data. Congratulations, you now have live binding data. It's really a rad set of technologies. Select eyes, front end people probably know about it. It's a selectation kind of object, and you don't know about jQuery and other bits and pieces. So yeah, every single thing we looked for was in there in NPM and officially maintained. Also more to the point, actually, that's the next slide. On that topic, the way front-end people have thought about NPM has changed rapidly over time. So select eyes is probably the most common stylable, dynamically adjustable select box replacement on the internet. You will see it most times you visit a website that has a styled select box, it's probably going to be select eyes. 2013, Brian, who makes select eyes, said, nope, it's not a node package, I'm not going to put NPM onto it. He was berated for 2 years. On January 30 this year, he caved in and published it. Basically, it got to the point where people were going to fork select eyes if you didn't put it on NPM. What I was going to say a second ago as well is that there's more than just DOM manipulation and like binding tools that front-end code needs. There are cool algorithms, there are library things like underscore ES6shim. You might need like consensus algos. You might need, in our case, country data. ISO 3166 alpha 2 codes for every country on the internet. Currency data. The Strike guys actually published some really cool currency libraries on NPM as well. Super Agent, which you probably know from Node, also works in the browser. If you've ever used jQuery's horrible jQuery Ajax, you know how bad it is. Or if you've ever used just XHR, you know that's awful as well. Super Agent has a very simple function signature, which pretty much just matches, get, here are my parameters, here are my headers, go. It's nice. It fits. It's also, you'll know it, it's also nice in terms of, you'll know it from Node land. It's nice to have the same thing in the front end as well. Your front end needs a lot of other things besides data bindings and DOM manipulation. If you want to write a state machine, don't be the guy who writes his own state machine. There's a billion great state machines maintained by 200 or 300 people each on NPM. So go find stuff. Don't write it yourself. What about things that aren't NPM? Well, globals are dead. Require.js never had a module directory, so it's dead. UMD only exists because of globals and because of Require.js. So right now I think that's dead code. If I see a thing that has a UMD declaration at the top, I generally fork it and delete the UMD. And there's not many ES6 packages in the world right now. You have a few choices when it comes to using NPM, and the process for delivering front-end code via NPM modules is called bundling. You take your thing, which required a bunch of other things, and they in turn required other things. You wrap it up into a bundle and you deliver it to the browser. Because this is part of the same build task that front-end people would do when they're also doing things like turning their Sass into CSS and all that kind of stuff, there's a couple of different options there. Gulp is super popular in front-end already. A lot of the tools that are built for handling bundled NPM code built around Gulp and browserify. It's got great example code. Gulp's been around for a really long time. Can't take over from Grunt, which you probably know if you do front end stuff. NPM, you don't necessarily need Gulp. Like a lot of Gulp plugins are actually like Gulp wrappers around existing things, and a lot of people said, well, NPM already has a build step that's part of my module. Why don't I just NPM run script build, and rather than calling Gulp wrappers to things, just call the Gulp thing. So no Gulp Sass, just call the Node Sass module. So that's another option. I'm kind of thinking about it because it's more lightweight than Gulp. Like I like having less code. I'd rather having Gulp wrappers and around things and things. Could be nice just to have things. There's also Webpack, and I'll talk about Webpack in a second because that's another way of bundling that's not browserify, which is what the most common way of bundling is. Webpack. Webpack can bundle NPM packages. It replaces the build system as well. The size of the modules, I'm going to send out a reference to this after the talk, it's slightly more efficient about how it makes the bundles, and it gives you a little bit more control over how it makes the bundles as well. So you can end up with a smaller result with Webpack. Webpack can also do AMD and browser globals as well, but I don't care about that, so it's not, in our case, it didn't really help. We use an existing bunch of Gulp tools, so right now, like that size benefit that Webpack would give us isn't worth it, but we're watching and seeing how things develop over time. So, one final thing before we get started on how to actually do NPM in the browser. We don't have a lib directory in our node code at all, and same thing with our front-end code. It's just modules all the way. I actually got this from Isaac, NPM Isaac. He uses it in his personal project. I actually thought it was part of the NPM coding guidelines, and I remember reading about it years ago. But the idea is you just make your own stuff as modules. He does it for his personal projects, but it's not an official part of the NPM design. But it's useful. Modules are a reasonable unit of granularity. When you make a thing that you think other people would find useful, you can open source it pretty readily. My contributions to NPM have gone way up since, things like, browser debug mode, that's like an original package, has no proprietary business value, cool, NPM publish, and you'll get patches and updates and other people working. One thing, if you are doing modules everywhere, rather than no lib directory, is that you'll suddenly look at your modules directory and there'll be a bunch of generic stuff and there'll be a bunch of original code. After the talk, I'm going to send you a link to a gist, which makes a Sublime project file if you use Sublime. which just raises the prominence of any NPM module which has private set to true. So that means you don't have to stare at a whole bunch of boring stuff when you open up your node modules. So here's how to bundle stuff. Here is JS source index.js. This is the first and last line. Cert simple front end is exactly like any other NPM module. It's var $ equals require jQuery, comma, foo equals require foo, etc. Module exports something. I normally module exports a function if something needs some kind of setup. But yeah, cert simple front end is just another NPM module, and it requires things from, it requires front-end packages, requires select dive, requires jQuery, etc. To turn JS source index.js into the actual distributed JS dist index.js, we use a thing called browserify, and we use it via gulp. There used to be a thing called gulp-browserify that got replaced by just use browserify. And this is actually, this example, which is actually from our real gulp file, is taken pretty much verbatim from actual gulp docs. So if you used gulp-browserify and got scary warnings about how it's not maintained anymore and you don't need it, the replacement is actually not like that. Basically, there were some differences about how browserify has its own streaming thing and gulp has its own streaming thing, so they decided to get rid of gulp-browserify because it was doing bad stuff. But it's pretty simple. Like you would say, like, we're going to take this file, we're going to poop out index.js, we're going to do some stuff to it in memory, and then we're going to save the output into this directory. Uglify is obviously minifying. We have some debug stuff, etc., and some other bits and pieces. I'll explain distify in a second. But it's actually, I mean, that's like 9 lines of code. It's pretty simple stuff. And that gives us the bundle that we will then use in the browser. And you run this when you run gulp.js and just run gulp, etc. Then how do you bundle things that aren't templates? You might have a lot of like .mustache files or other kind of template things that aren't JavaScript that you want to deliver to the front end. There's a thing called BRFS, which is browserify file system. You'll see it in the way you include something that's not JavaScript is you have a browserify section in your package JSON, and then you just add this transform and then an array full of with one item, which is browserify.fs. The way you actually load a file inside your module is just rfs equals require.fs, just like it was Node, and then you do an fs read file sync. And it's not actually doing like a read file sync. It's not going to do any kind of synchronous stuff in the browser. It's not going to Ajax download this or anything. The browserify, when it sees this, or BRFS specifically, browserify file system, will actually immediately inline this as part of the bundling process. So what you deliver to the browser will actually still be that JS source dist index.js, that one file with everything you're requiring, everything that requires, including these things. So yeah, there's no Ajax downloading, there's no like waiting around for synchronous operations. It just has the same name as the equivalent function in Node. Thing that sometimes keeps people away from browserify is final size. You're all Node developers, you know that Node does a whole tree. Things depend on things and they are installed underneath other things, etc. So when people start using browserify, they kind of wonder about where their stuff is going. So there's a great little tool called Diskify. You go Diskify your bundle, and then it actually outputs like this live little thing. So you can see, so that simple itself is a 400K bundle. It's a, you visit certsimple.com, this is a 400K download. That's minified. I think unminified is huge and awful. We went production and I forgot to turn on minifying. No one on Hacker News noticed they were downloading a 2 megabyte website. So there's browserify itself and then all my Node modules. Okay, so what's the biggest Node module? Well, there's cert simple front end, which seems quite reasonable. ES6shim, I generally use ES6shim rather than using underscore these days. It looks more JavaScripty, jQuery, Rackniv. These are all things that I've just gone, var $ equals require thing, and they've been included in the bundle. Another thing is an example of how this is useful. When I first launched this site, country data is actually huge. It's got information on like currencies and where the decimal point on the minor units are to make the major units, like X amount of 1,000 rupee, like 1,000 Indian small minor units make one Indian major unit, or 100 cents make $1, all that kind of stuff. It actually turns out to be like a few hundred K of just information about countries. And all I was really interested in was the country codes. So I actually ran this to find out where all my space was going and why my module was huge. And it was really easy to see that country data was eating 3/4 of the module size, and just made a quick little thing to like iterate through country data and spit out a smaller module based on that. So, cool. Another thing that's worth noting, this is a real like brain dump of everything I know about not everything I know, really everything I consider important about using NPM in the browser. So it's moving quickly, but I'm trying to focus on like things that will basically help. Yeah, as you know, like when you deploy things via Node, you have a package.json which says what your dependencies are. So you might have a package.json that says I need a version. So you might have a package.json for a package called A, which says only exactly use B version 1.20, nothing newer, nothing older. And when you first start doing Node, you might be under the impression that kind of locks down what all your dependencies will be. But B has its own dependencies, and B itself might not be as exact about saying its dependencies. So, all right, my package is A version 1, requires B exactly version 2. B version 2 says use any version of C. So therefore, what I have on my Mac, what I have on my Linux box DigitalOcean, could actually be running a different version of C. The people a few years back used to check in all their Node modules as part of this, which also applies to NPM in the browser. These days, people are starting to use NPM shrinkwrap, which is actually just a way of snapshotting the whole tree. So A version 1 depends on B version 1.20, which depends on this exact version of C. And it's like just a npm-shrinkwrap.json, and it's just a full snapshot of everything in your directory. Also, as well, snapshotting tells you about things like packages that have stuff installed in their Node modules that isn't in their package.json and other useful bits and pieces. npm shrinkwrap is built into NPM as well. It's not perfect. It has a few things that are slightly annoying about it, but when you redo the shrinkwrap file, you basically delete the old one, make a new one, inspect it in like whatever you use your diffing tool is in your source control program, go, yeah, that looks right, check it. It generally makes good decisions, so I haven't ever had a problem with it, but you actually have to manually delete the file and recreate it. It's only looking at what was already in your Node modules plus whatever you added, so it shouldn't be that different, but it's always good to actually look at it. And yeah, it avoids the overhead of committing Node modules. It means your Git repo doesn't have a whole bunch of unrelated stuff that you don't maintain. So npm shrinkwrap is pretty cool. So I hope that was useful. Everything is on npm, not just front-end stuff, but general JavaScript stuff that you shouldn't write yourself, that your front-end probably needs. Don't be the guy that recreates his own state machine or his own consensus algorithm because you're all box packing thing because you're doing that on the front end. The front end guys need to start front end people need to start reusing stuff that's out there and not rewriting everything. Currently they tend to use libraries, but only for DOM manipulation type stuff. That needs to change. NPM can help with that. You have these bundles that are built by browserify or Webpack. Use BRFS to include non-JavaScript files. Use Discofine to watch your bundle size. Use shrinkwrap for consistent deploys. I'm reading off the screen here, but and if you get tired of looking at other people's modules, use a .sublime.project file, and you can have it focus on just your own projects. Thank you. That's my talk.